Hello, dear students. Let's see this question of JEE Advanced 2019. It's question of modern physics involving impulse and momentum also. So the question states, perfectly reflecting mirror of mass m mounted on a spring constitutes a spring mass system of angular frequency omega such that 4 pi m omega by h is equal to 10 to the power of 24 meter power minus 2 with h as a Planck's constant. N photons of wavelength lambda is equal to 8 pi into 10 to the power minus 6 meters strike the mirror simultaneously at normal incidence such that the mirror gets displaced by 1 micrometer. If the value of n is equal to x into 10 to the power 12, then what is the value of x? And the spring is a massless. So this is a relatively quite easy question. So this is a mirror of mass m, and suppose this spring has a spring constant k. And now what happened that beam of photon striking the mirror. Suppose this photon has a wavelength lambda. So this photon is carrying momentum p is equal to h by lambda, and that gets reflected back. So this mirror is perfectly reflecting, so it will reflect back. All the photons will reflect back. So I'm talking about one photon. So when it will go back, its momentum will be h by lambda in the backward direction. So change in momentum of one photon due to kind of a collision with the mirror will be twice h by lambda. And it is a perfectly reflecting mirror. So all the incident and photon will reflect it back. So total change of all incident photons, total change in momentum of all incident photon will be n times of twice h by lambda, and that is actually the exactly the impulse acting on the mirror. So if I talk about the impulse on mirror, due to all photons, so that impulse will be n times of twice h by lambda. And because of this impulse, that mirror will get some velocity. Suppose mirror gets velocity v immediately after the impulse. So from impulse momentum theorem, this impulse will be change in momentum, and change in momentum would be mv minus 0. Initially it was rest, so that is the final momentum. Now it's simply a kind of a conservation of mechanical energy. So it has all the kinetic energy will be converted to spring potential energy when it will reach to a state of the maximum compression. It reaches somewhere here. Suppose it gets compressed by distance x. So whatever kinetic energy is here right now, that will be converted to the spring potential energy. So we can simply write the equation half mv square is equal to half kx square. This half of gets cancelled and m is there. Value of v I can put from the first equation. So if I put the value of v, that is twice nh by lambda m, and have to square, and actually this k was not cancelled, half was cancelled. So and k is equal to the angular frequency omega given is omega is equal to square root of k by m. So k is equal to nothing but m omega square, m omega square, and this is x square. So let me make this m, and that m will get cancelled. So that will become 4 n square h square, and let me take this lambda m on that side. So lambda square m square omega square x square. In the question it is given that four pi m omega divided by h is equal to 10 to the power 24. So this is 4n square h square. That is not just straightforward matter of putting the values. So here lambda square. In place of m omega, I can put this h into 10 to the power 24 by 4 pi. So that will be h square 10 to the power 48 and divided by 4 pi whole square, that will be 16 pi square, and their x square, this h square will get cancelled, and you just put all the value here. Suppose this is n square. Lambda has a value 8 pi into 10 to the power minus 6, so that will be 64 pi square 10 to the power minus 12. This is 10 to the power 48. X is 1 micrometer square, will be 10 to the power minus 12. And the denominator, this is a 16 pi square. This will get cancelled. That will become 4. 4 and 4 will get cancelled. So n, we will going to get 10 to the power 20. N square will 10 to the power 24. So value of n will be 1 into 10 to the power 12. So our x is 1, and that is our answer. Thank you.